Okay, so we're talking about one-to-one functions. The one-to-one functions, this is Mrs. Ross, I'm sorry, and this is 2.4 inverse functions, but we're starting with one-to-one functions. Functions in which each element in the range is associated with exactly one element in the domain. So there's two steps. The first thing you do is you determine if you have a one-to-one function, and then you apply this to the inverse of a function. So I need you to recall that if we look at this, if we look at this is a function. So 2, 3, 5, 4, and 7, 3. That's okay, because each x maps to only one y. Okay? This is not a one-to-one function, however. It's a function, but not a one-to-one function. For a relation to be a one-to-one function, each element must map to only one y. So we have the vertical line test to determine if a graph is a function. We have the horizontal line test to determine if the function is one-to-one. Okay. So here are some examples of one-to-one functions and non-examples. So if I take my pencil, this is my pencil. Oh, so pretty, so demure. Okay, and I run it this way, I'm only ever going to hit 1 point. Okay, it's just like the vertical line test is horizontal. So that's a one-to-one function. The same thing happens here. If I roll my pencil all the way down here, 1 point each time. Here's the problem. Over here, I'm going to hit 2 points. So that's not a one-to-one function. And the same thing happens right here. Not a one-to-one function. Oop. Yep, okay. So one-to-one function, a function is one-to-one if f of x of 1 is equal to f of x of 2 and x of 1 equals x of 2. Oh, sigh. Okay, so now you use the horizontal test to determine if this is a one-to-one function. So if I use my pencil, good gravy, don't make me draw it again. It's just so bad. And I run it down, I'm going to hit 2 points. So this is not one-to-one. This says, how do you determine if it's one-to-one without graphing it? First of all, I don't know why you wouldn't graph it. You have a graphing calculator and you have Desmos. But secondly, we'll go ahead and just use them. So we're going to insert two variables into this. We're going to insert x1 and x2 and see if we get those variables out. So 1 over x1 is equal to 1 over x2. And we're going to solve for those. So because they are both 1 over, I can say x1 minus is equal to, and then if I add 2 to both sides, I get x1 is equal to x2. That is a one-to-one. Super exciting. Okay. All right. Finding inverse functions. If the function is one-to-one, the inverse of the function will be a function. We're getting into some math language here. So if the function is one-to-one, the inverse of that function will be a function. So here's some facts about inverse functions. A function has an inverse if it is one-to-one. There are some functions that don't have inverses. For each ordered pair, okay, that's delightful. So what it's saying is the domain of one function is the range of its inverse. So the domain of f of x is equal to the range of, and this is how you notate inverse function. Okay. Right, that's what it says here on the third point. The inverse of f is notated by f to the -1. And then there's a note. It's not this. This is not what we're meaning. Of course, in math, we have to have more than one meaning for the same thing, because why would it not math that way? So just so you know, it just means inverse. Okay, domain and range of a function and its inverse, so they flip-flop. The domain of f of x is equal to the range of f of the inverse, and same, the range of f of x is going to be the domain of the inverse. Okay, so here's the steps to finding the inverse of a function. We replace f of x with y, and then we flip x and y, solve for y, and then you replace it back with that. Let's do some. Let's do this one. Okay. So it says for f -1, find the function Oh, find the inverse. Okay, so the first thing I'm going to do is replace that with y. And I'm going to switch x and y. So this becomes x and this becomes y. And then I'm going to solve for y. So I've got to get rid of that. Let me get a different color here. So I'm going to multiply this side by y plus 2 and multiply this side by y plus 2. This is going to cancel. I get x, y plus 2 is equal to 1. Then I divided this so that my x's would cancel. That's an x. Okay, minus 2, minus 2. Y is equal to 1 over x minus 2. Okay, if you look on the lesson and you look to see this solved, you'll see that they did this over x, and it's the same thing. 1 over x minus 2x, which is equal to 1 over x minus 2. So same thing. Okay, so that's a good answer. That's a good answer too. All they did there is they distributed that. Okay, let's keep on keeping. Domain and range of a function and its inverse. Find the domain and range for the one-to-one function. They already told us it was one-to-one of this and its inverse. So the first thing I'm going to do is my domain of f of x is that x can't be 2. Okay, so that's going to be, it can be literally anything but 2, but not 2. 2 is no bueno. Okay, and I know that the domain of f of x is equal to the range of f negative, or the inverse. Okay, so the second thing I'm going to do, let me change colors, because why not, is I'm going to find the inverse. Okay, so I have y is equal to x plus 1 over x minus 2. That's what I have right here. Okay. I'm going to switch my x's and my y's. So I have x is equal to y plus 1 over y minus 2. I'm going to multiply both sides by y minus 2 because fractions are mean. X, y minus 2 is equal to y plus 1 because these are going to cancel. What did I do then? Oh, I distributed. So I'm going to distribute this x. So I have x, y minus 2x is equal to y plus 1. And then I'm going to start combining like terms. Like I'm going to add this over here. xy is equal to y plus 1 plus 2x. And I'm going to subtract this over here. So we need to get our y's on the same. I'm going to factor out the y. And then I'm going to divide by that. So that gives me, how many times can I go up here? Okay. That gives me y is equal to 1 plus 2x over x minus 1. Is that the answer? Praise the Lord, it is. Okay, let me change colors. So we know that the, okay, I wanted a different color. Did I get one? I did, it's green. All right, so we know that the domain of f minus x is negative infinity to 2, 2 to infinity. And then the range, so whatever x can be, oh, my bad, flip that. My bad, flip that. Sideways. This is the range. Because of this right here. This right here. I got confuzzled. It happens. So this is domain. So I know that x can't equal 1. Like this cannot equal 0 right here. Okay. So this is going to be negative theta to 1 union 1 to theta. And that's your domain and range. Now you try. Oh, mercy. Okay. So whenever we talk about domain and range, just a reminder, I literally write this almost every time just so I remember what it is. And if you need a primer on that, I can talk to you about our cousins from Arkansas. So the first, it says find the domain and range of g of x and its inverse. So domain, which is x because of Dixie, we know that 5x minus 1 can't equal 0. So we're going to solve for that x. 5. X can't equal 1/5. So my domain of g of x, this is of g of x, is negative theta 1/5. 1/5 to, did I say theta? What am I making words up for? It's infinity, my bad. So the domain of f of x is equal to the range of its inverse. Okay, did I just say f of x? Again, losing my mind. We're going to pretend this is g. It really doesn't matter what you call it, but that's okay. And I'm going to change colors because why not? So I need to find g of negative 1 inverse. Okay, so if this is currently this, I'm going to switch my x and y. So then I'm going to, so that's x times 5y minus 1, 3. Oh, I distributed. 5xy, I distributed this like this. Minus x is equal to 3. I got rid of this because I'm solving for y. Divide by 5x. Y is equal to 3 plus x over 5x. Cool. So I know, let's get another color in here. So I know that the range of g negative 1x is equal to this domain. So that's this 1/5 union 1/5 infinity. And then my domain, okay, so x cannot equal, if this is my inverse, x cannot equal 0. So that means I'm going from negative infinity to 0 union 0 infinity. Okay, let's see if we can at least do a couple more. Okay, determine if each of these, if the inverse of each of these is also a function. So it's asking if these are 1, 2, 1. Okay, remember we have our pencil for our horizontal, oh mercy, you know, Mrs. Ross, really. And this is going this way. So yes, this is 1 to 1. If I do the same thing here, I'm going to hit some of the same points. So no, not 1 to 1. Okay. This again, if I do the horizontal line test, yes, this is 1 to 1. And this is also, yes, 1 to 1. Okay. All right, I'm going to do a second video for this question because I don't want to run out of time. So this will be part 1.